Okay, let's take a look at the next one, which is problem 22. If you look at problem number 22, once again, there's nothing that I can factor out of each one. So what I'm going to do is I'm going to do what I was doing before. I'm going to pull this apart, and I know that 7y times 4y gives me 28y squared. I'm going to come over here and I'm going to do the same thing. I know that I have a negative, let's do a negative 3 and a positive 2. Let's just check and see. When I cross multiply here, I end up with a what? Positive 14y. And when I multiply it here, I end up with a negative 12y. And when I add those together, I end up with a positive 2y, which is not the 13. So therefore, the combination that I came up with here will not work. So I'm going to have to start all over again. I'm going to stay with the 7y and see what happens. This time I'm going to switch these around. Suppose what happens here is that I end up with a, say, a 7y and a 4y, and this time I'm going to make it a positive 2 and a negative 3. Well, let's cross multiply again. When I cross multiply there, I end up with a negative 21y. When I cross multiply here, I end up with a what? Positive 8y. And when you add a positive 8y and a negative 21y, you end up with a negative 13y, which is the middle term. So therefore, I know that I have my answer. Now remember, your answers are not the diagonals, but actually the ones that are adjacent from each other. So therefore, the answer for here is going to be 7y plus 2. And also, here's the other set, which is going to be 4y minus 3. So here is my final answer for that one. Now, the next one we will take a look at will actually end up being this particular one here, where we notice this time is two terms, and we look like we have cubes. So I'm going to look for a difference of cubes. So the cube root of 8 is 2, so I'm going to put that in parentheses, and then I'm going to do this one as well, because I know 3 times 3 will also make 9. Now, what do I have? I have a difference of cubes. Difference of cubes, remember, you will set up two sets of parentheses, the negative will go here, and I have a positive and a positive. So I'll put the 2p here, and the q to the third here. To fill out the first term, I'm going to take my 2p, and I'm going to square it. And when you do that, you end up with 4p squared. I'm going to do the same thing here. I'm going to take this last term that I have here, which is q to the third, and I'm going to square it, which ends up giving me q to the sixth. And to find my middle term, I'm just going to multiply these two terms together, which is 2p times q to the third, and that ends up just being 2p q to the third. So therefore, here's my final answer, which is here. So that becomes now your final answer. And for the last problem that we're going to look at quickly will be what happens when we happen to have something to the 6th power. First thing you're always going to do is you're going to look and say, is there a difference of squares? If there is, you must do that first. So I'm going to do this, because that will give me the difference of squares. Well, that will be a 3, and that's also to the third. So therefore, I do have a difference of squares. And a difference of squares will state for you that there's a positive and a negative. So it looks like I have an x to the third, and an x to the third, and a y to the third, and a y to the third. Now notice when you look at this, here you have a sum of cubes, and if you notice over here, you also have a difference of cubes. So once again, you're going to have to factor once more, taking this one. So first, let's factor the sum of cubes, which is the first set of parentheses. Once again, I'm going to set up my parentheses. I know it's going to be positive, negative, positive. The cube root here is x. The cube for that one is y. To fill in these other terms, to fill in the first one here, I'm going to take the first one here and square it. Take the last one and square it, then multiply the two together. So that takes care of the sum of cubes. But I also have, if you notice, a difference of cubes. So I'm going to have to do the same thing with that one. Set up my parentheses once more. Since this started out as a negative here, this will always be a negative and a positive and a positive. Take the cube root of the first term, the cube root of the second term. Now to fill in the other three, I will use the first set of parentheses. The first here, what I'm going to do is take this one and square it, take my second term and square it, then multiply the two together. Now notice here, if you take a look at this answer, this is your complete factored form. So therefore, the answer for this problem is actually all four terms. It's x plus y, but it's also x minus y. It's also going to be x squared minus xy plus y squared. And it's also going to be the last one, which happens to be x squared plus xy plus y squared. So all four factors are what you'll have when you have x to the 6th power and y to the 6th.